And the next thing we're going to talk about, next lesson is going to drive us, the question is, how do we find the domain and range of a function? Of a function. Okay? We're going to look at functions, and we want to know how we find the domain of functions. And some people also might call this restricting domains to make things functions. And we want to look at, first we're going to look at equations, and we want to find the domain and range of functions. So the first one we want to look at is y equal to the square root of x squared minus 1. Okay? We're going to look at x squared, the square root of x squared minus 1. We want to know first, we want to put some restrictions on our domain. What could our numbers in our domain be? And the first thing I want to look at, say, we'll plug in, say, x equals 1. X equals 1. So we're going to plug in x equals 1 and see what's going on here. So y equals 1 squared minus 1, which is 0. That's fine. Okay? So it's 1 minus 1, which is 0. The square root of 0, which we all know is 0. All right, so that's fine. Let's take a look and say x equaled negative 1 equals negative 1. And let's see what happens here. We're going to plug in our negative 1. And remember, use our parentheses. I'm always using these parentheses. Less mistakes to be made. Negative 1 squared turns out to be positive 1. 1 minus 1 is 0. So we get the square root of 0, which is 0. It's all perfectly fine. Let's see what happens if x equals 0. X equals 0. So we say y equals the square root of 0 squared minus 1. 0 squared is 0. Take the square root. 0 minus 1 is negative 1. Uh-oh. Uh-oh, that's bad. Right now, we're only dealing with real numbers. The square root of negative 1 is an imaginary number. For us, they don't exist. Not right now. Not until you get into complex analysis. And that'll be a different course after you've gone through calculus and stuff like that. So we don't deal with this. So that's bad. So that is bad. Must be real. Okay, so for us, functions have to always be real. Okay, so there is, we take a look at our domain, so we can't be, x cannot equal 0. And so other than that, everything else is fine for x, our domain. Okay, and remember, that's an important fact, and we're not really going to see it. We're not going to deal with imaginary numbers anymore because we always have to be, for us, functions have to be real. So that's our restriction on domain. So x cannot equal 0. So there's our restriction on domain. X cannot equal 0. Let's take a look at another one, and we'll erase this, another equation.